Hi everyone. We're going to be talking about limits. Um, some of you all might have heard of this term in a mathematical or in the context of physics before. Um, so, what are limits? They or a limit of a function is the value that a function takes as it approaches a particular x value. So, to give a very crude definition. Now, why do we study limits? Why do we need limits? For example, or more like to understand what limits do, right? Um, Suppose you want to weigh a ball. You have a ball, you want to weigh the ball. You use a very cheap um, bathroom scale, for example, to measure the ball. It gives you value without any decimals, gives you the value or the weight of the ball. Now, you use a better, more expensive, and a better calibrated scale that can give you up to two decimals. Well, that gives you a slightly more accurate value of the actual weight of the ball. Then you use an even more expensive scale, and that's even better calibrated. It goes up to five decimals, say. That's even closer to the actual weight of the ball. Now, in terms of physics, there's no actual or perfect measurement or scale. Uh, we've just chosen scales for different kinds of measurements, right? So there's no perfect measurement. So we can keep going and going and going and measuring up to how many ever decimals we want, and we keep getting closer and closer and closer to the actual value or actual weight of the ball. So the idea of the limit is that you approach the actual weight of the ball as you use better calibrated scales. So if you think of it in terms of math and functions, say you have a function that's defined by f of x, that's given by y equals f of x. That's a function, right? Now, question is, what is the value, what is y as x goes to x0 as x? So what does goes to mean? So in terms of limit, um, you would ask something like, what is the value of y as x goes to x0? This is read as goes to, right? So what that means is that you consider some x, you have an x naught or x0 that is given to you, and that's where you want to know the value of the function. For some reason, you cannot directly plug x0 in your function to measure it, say. So you want to approximate, right? So you have x0, then you consider an x that's close enough to x0. You find the value, you're able to plug in this x value in the function and say what the value is. Then you move slightly closer to x0 as compared to x, and then you find the value of the function at that value, at that x1, say, and then you go to x2, which is even closer to x0 as compared to x1, and you find the value of the function at x2. And you keep doing this, going further and further and further and further until you're so close to x0 that you're almost there. You're not exactly at x0, going back to the weight of the ball example, you don't know the exact weight of the ball, but you're almost there, right? So you're going so close to x0 that you almost have you're able to approximate the value of the function at x0. You almost know what it is. You can say that the function value approaches say f of something, or say y0, the function approaches y0 as x goes to x0. That is the concept of a limit. An application of this is something that you're all probably familiar with, the concept of velocity. Mm. As in comparison to speed, which is defined as the distance covered over time taken to cover that distance, velocity is defined as the instantaneous rate of change, right? Of distance over time, or with respect to time, right? That's velocity. So if you cover distance x in time t, your speed is going to be x over t, right? However, velocity also, you define it in terms of, I guess, displacement as opposed to distance. So what you're doing is you're saying, suppose you have that um, over t plus delta t minus t minus x. So that's the displacement. This is the displacement that happens in time. So you're doing limit as delta t goes to 0. So the idea is that you're not, you're moving very forward slightly in time, say from 1 second to 1.00001 seconds, and you're checking how much your car has moved in that time. And so the idea is that you approach the value, the value of the speed, um, or the velocity as your change in time goes to 0. So that's the idea behind, or that's an application of limit, as we can see here.